So now let's move on to the non-parametric tests. So these are also called distribution-free tests. So if you run normality, and then if your data is not normally distributed, then you will opt to use the non-parametric equivalent of the parametric test. So if we recall, statistical test falls into two types: the parametric test, which assume that data follows a particular distribution, so that's normally distributed, and for the non-parametric test, these are usually based on ranks, signs, rather than actual data. And this is for non-normally distributed data. So we have ranking, so we would use ranking, so that's the Spearman row rank, and that is a non-parametric test. So non-parametric techniques are usually based on ranks as previously mentioned, and if there is a scale data, it is ordered and ranked, and analysis is carried out on the ranks rather than on the actual data itself. And mostly non-parametric tests are for data which are ordinal or for data which does not follow any particular shape, and assumptions underlying parametric tests were not met, and when the data is also skewed, and for the data is having some potential outliers, and for small sample sizes. So parametric tests are fairly robust to non-normality. Okay, so and data has to be skewed to be a problem on distribution. So for normally distributed data, okay, so if you look at this one, only the first, this one and this one with a yes are looking normal, while the other is skewed. What can be done about non-normality? So if the data are not normally distributed, there are two options. Either you use a non-parametric test or you transform the dependent variable. For positively skewed data, you take the log of the dependent variable, which often produces normally distributed values. If we are going to compare parametric versus non-parametric, so for the independent t-test, the data, what to check for normality is dependent variable by group, and if it is non-parametric, you will use the Mann-Whitney test. For the paired T, you will use the Wilcoxon sign rank test. For the one-way ANOVA, you will use the Korskal-Wallis. For repeated measures ANOVA, you will use the Friedman test. And for Peterson's correlation coefficient parametric, for the non-parametric equivalent is you will use the Spearman's correlation coefficient. And if your parametric test is linear regression, the non-parametric equivalent is the non-transform. There is none. So uh, there is no non-parametric equivalent for linear regression. Otherwise, you will transform the data. So if we have this comparison of housework, so its test should be carried out to compare the hours of housework for males and females, and looking at the histogram of housework by gender. So this is the male data, this is the female data on top. So if you take a look, and the male data is very skewed, so we will use the Mann-Whitney test. And in summary, if we are going to remember, your dependent variable is if it is a scale and it is normally distributed, you use parametric test. And if it is skewed, you use non-parametric. If it is categorical and it is ordinal, you use non-parametric. And if it is categorical and it is nominal, you use the chi-square. So in the Mann-Whitney, okay, so you will be faced with the research question. Does drinking the legal limit for alcohol affect driving reaction times? Okay, so if you drink beyond the legal limit for alcohol, does it affect the reaction time? So participants were given either alcohol or non-alcoholic drinks, and their driving reaction times were tested on a simulated driving situation. So they did not know whether they had alcohol or not. So these are the placebo and these are the alcohols. And then if you are going to run that in the Excel, so you have your group, the reaction time, and the rank. You're using Mann-Whitney test. So that is the non-parametric equivalent for the independent t-test. And the data from both groups is ordered and ranked, and the mean rank of the groups are compared. So if we are going to look into the null hypothesis, you would say that there is no difference between the alcohol and the placebo populations in terms of reaction time. And your alternative hypothesis, you would say the alcohol population has a different reaction time distribution to the placebo population, and you're going to use the test statistic, which is the Mann-Whitney mu. Okay, and then test statistics, the mu can be approximated to a z to get the p value. So, uh, do not be confused on how these hypotheses are going to be stated. They are only needed to explain hypothesis testing for actual research. And if we're going to have that is the result already, you have p-value, which is 0.008. So that means to say there is highly significant evidence to suggest that there is a difference in the distributions of reaction times for those in the placebo group and those in the alcohol groups. And here, that is going to be the result. So when you run that in the SPSS, so you will click Analyze Non-Parametric Test and you will have related samples.